Welcome back to the second class in electricity. In the previous class, we discussed what is electricity, what is electric current, and what is electric potential. So starting from that potential, today we are going to discuss potential difference, which is a very important concept. But before going to the potential difference, let us directly come back to this diagram. We can see here two containers filled with water. These are the two containers filled with water, and these are also two containers filled with water. In this first diagram, A and B are the two containers where the height of water, that is the level of water, is equal. In the second diagram, we have seen in the container P, the height of water level is high, and here the height is less. Now, if container A and B are connected with a tunnel, similarly P and Q, if they are connected with a candle, then the question arises, will water move from container A to container B in this diagram, or from B to A? Similarly, the question will arise here, will the water from container P to move to Q, or from Q to P, or there will be no movement of water? Answer is very simple. We will see there will be no movement of water from A container to B container. Neither the water will move from container B to container A. The reason? The level of water is equal in both the containers. But here in this diagram we will see the container P, since there the water level is higher, and in container Q the level of water is lower. So from P the water will move to container Q. But water cannot move from container Q back to P because the level of water is low there. If we come back to this third diagram, we will see these are the two containers. One container is small in volume, the second container is bigger. In this, definitely the water also will be less in amount, but the water will be more in this container. My question, will water move from this container, that is smaller container, to the bigger container, or water will move from bigger container to the smaller container? This time also answer is very simple. Since in the small container, the height of water is more, and in the bigger container, the level of water is low. So the water will move from higher level to the lower level, irrespective of the size of the container. So from these three diagrams, it is very clear to us that it is the difference between the level of water and not the quantity of water in the containers which determines the direction of flow of water. Means water does not flow from a bigger container to smaller container, or from more amount to less amount. But what determines the flow of water? It is very simple. Water will always flow from a greater height to a lesser height. Similarly, we will see when heat is to be transmitted from one place to another, we need also a difference of temperature. Means heat will always move from a more hot object to less hot object. Similarly, water will move from higher height to lower height. Now, if these are the two conditions for heat and water, will there be any conditions necessary for flow of electric charges? The answer is yes. Similarly, for the flow of charges, it needs a difference of electric potential. Like for flow of water, there is a difference of height. For the flow of heat, there is a difference of temperature. Similarly, for the flow of electric charge, we need a difference of electric potential. Now, what is electric potential? We have discussed in our previous class. Electric potential is the amount of work done in moving a unit positive charge from infinity distance to a point within an electric field. So, let us try to understand this. The positive charges will always move from a higher potential to lower potential. Like water moves from a region of higher height to lower height. Heat always transferred from more hot body to less hot body. Similarly, positive charges always move from a region of higher potential to a region of lower electric potential. This is for positive charge, but for negative charge it will be opposite. What is that? But the negative charges will move in the opposite direction, that is from a region of lower electric potential to higher electric potential. That is to say, if A and B are 2 points and between the 2 points electric charges need to move, then definitely at point A and at point B, there should be a difference of electric potential. That difference in the electric potential we call as electric potential. In simple word, we call it as voltage. Let us try to understand by this diagram. We have here the two containers, container 1A and container B. Imagine this is full of positive charges and this is full of negative charges. We have kept this onto insulator stand. Now at this container there is more potential and in this container there is less potential. So what will happen, since there is more potential in this container A and less potential in container B, if we connect the two containers with a conductor, then the positive charges will always travel from a region of higher to lower potential. From higher to lower potential, positive charges will move. And in this diagram we have seen, these are negative charge and these are positive charge. Since there is high potential and there is less potential, the negative charges will flow in the opposite direction. Means positive charges will always travel from a region of higher electric potential to lower electric potential, and negative charges will move from a region of lower electric potential to higher electric potential. So though the conductors, through a conductor only the negative charges, that is electrons, can move. We know it, that metals have free electrons, and due to presence of those free electrons they can conduct electric current. Means the negative charges, means the electrons, they move through a conductor. We know it, and basically this flow of negative charges is called as electric current. But conventionally we do not use this. What is that? It's given. But the direction of flow of positive charge is taken as the direction of current. It is because long before the discovery of electron, that is before we could come to know about the negative charges, electricity was discussed, and at that time conventionally it was taken to be the direction of positive charge as the direction of current. So still, in respect of those great scientists who discussed electricity even before the discovery of electrons, we still assume that the direction of electric current is the direction of positive charges. But now let's come back. What is potential difference then? In our previous class we have come to know what is electric potential, but now our topic to discuss is potential difference. So potential difference between 2 points in an electric field is the amount of work done in bringing a unit positive charge from one point to another within the electric field. So it is almost similar to the electric potential. You see, there is a difference. In electric potential we got, it is the amount of work done in moving a unit positive charge from infinity to a particular point within electric field. But potential difference is also the amount of work done in moving a unit positive charge from one point to another point within an electric field. So that is the difference. To understand this, let us come back to this. Let A and B are 2 points. To understand this, we have this diagram. This is A is a point and B is a point on this number line. Now these two A and B points only, but at a distance there is a source charge capital Q, which is a unit positive charge. Source charge capital Q. And the capital Q has an electric field in this direction. This is the electric field, which is a circular region, and this is at infinity distance. From infinity distance we are pushing another positive charge, small q. From infinity we are pushing it to place A, or we may push it to place B. Means we are pushing the charges to two different points A and B. Under that condition, what's happening? Work done in moving the charge small q from infinity to A. When we are pushing the charge from infinite distance to A, which charge? Small q charge, then definitely we are doing some amount of work. Similarly, when we are pushing the small q charge from same infinity to another point B, then also we will be doing some amount of work. So we are doing together two different work. What are the work? First, work done on moving the charge to point A, and the second, work done in moving the charge to point B. Now, work done in moving a charge from infinity to a point is called as electric potential, what we call as V. So we got in our previous class V is equal to W by Q. Means electric potential is equal to work done divided by charge. Similarly, we will get here V means potential, where at point A, which we are representing as VA, VA, this is the electric potential at A, will be W by Q, but work done at place A by Q. Similarly, potential at B will be VB, and that is work done at point B, WB by Q. Now, since we are doing more work in pushing the charge to B than A, so obviously VB will be greater than VA. Means potential at point B will be more than potential at A. So the potential difference between these 2 points A and B will be VB minus VA. VB minus VA. But what is VB? VB is, we have got WB by Q. We are putting it. And minus VA means WA by Q. So we are getting WB by Q minus WA by Q. And by simplification we are getting that is potential difference between these 2 points will be WB minus WA by Q. Here, if WB by WA means work done between the 2 points, work done between these 2 points, that is we are getting WB minus WA. If this is equal to 1 joule, means if we are doing 1 joule amount of work in moving the 2 charges from A to B, and the amount of charge, small q charge is 1 coulomb, then we will get VB by minus VA, means potential difference is equal to work done by charge. What is the work done? 1 joule, and amount of charge 1 coulomb. So we are getting 1 joule per 1 coulomb, that is we are getting 1 joule per coulomb. 1 joule per coulomb is called as volt. So potential difference between these 2 points is called as 1 volt. So what is there for 1 volt? You will get, if 1 joule amount of work is done in moving 1 coulomb charge from one point to another, then the potential difference between the 2 points within the electric field will be called as 1 volt. That is to say that when this small q charge is equal to 1 coulomb, and while pushing the charge from A to B, you need to do a work of equal to 1 joule, then the work done is 1 joule while bringing this 1 coulomb charge. So between these 2 points, potential difference will be 1 volt. So this is how electric potential is calculated, and this electric potential is very important for the transmission of charges from one place to another. Remember, positive charges will always travel from a region of higher potential to lower potential, and the negative charges will always travel from lower potential to higher potential. That is to say, for the movement of charges, definitely we will have to apply a potential difference. How do we apply the potential difference at the two ends of the conductor? This is by using voltage, that is the battery source of current, electric cell. And we will discuss later on electric circuit, because after studying the electric circuit, we will go to Ohm's law, and we will meet you again next time. Thank you.